Hello and welcome to Motorized ball valve review. I received those two items. Uh, those are motorized ball valves for water treatment. This is a standard water valve with two inner 3/4 of an inch thread and an electrical gearing above it. This is the package, not sure if they were packed like this. I've already opened the box earlier. Two of them are identical. The spec says it's 12 volts, 1.0 MPa, which is exactly 10 bars, pressure, max temperature of 100 degrees Celsius, and a maximum power consumption of 2 watts. It has 3 wires for controlling the valve position. Go inside a plastic case with proper sealing. You can see it. The plastic box contains reduction drive and a motor for driving the valve. It's mounted above the standard valve case made of brass with plastic seal, a typical ball valve. The valve itself has a special mounting area with threaded holes. You can see it here and here. Now let's see how it works. Following the specification, connect the yellow wire to the negative power source terminal. Powering the red wire opens the valve. Let's see how it works. Place a piece of white paper so you can see it. Okay. As the valve is closed, the blue wire has no effect, and the red opens the valve. After the valve has opened, powering the red wire has no effect, except you can hear relay clicking inside the box. Powering the blue wire causes the valve to close. Powering it again when it's closed causes no effect and no relay clicking. Now we carry out an interesting test. Let's open the valve. Now it's open and we power up both the blue and the red wires simultaneously. Nothing happens. Okay, let's close it now. And now close the valve. Now it's closed, and then we power up both the blue and the red wires simultaneously. This causes the valve to open. Well, that's a shame. Probably the closed state of the valve is the safest one. Not always, but this is the case. This is not the behavior I expected. What I like about this product, you can partially open and close, i.e. increase and decrease the water flow by powering the red and the blue wires temporarily. So let's see how it works. Closed partially and opened. So you see, you can control the water flow. Okay, let's see what's inside. There are 4 screws here. Let's unscrew them all. And the upper part of the case is off. Okay. Underneath we can see a PCB and a relay, which we heard clicking. Now unscrew this PCB. Underneath the PCB we can see a diode and a capacitor. Okay. This is a plastic cover protecting the PCB from contact with reduction drive metal side. Unscrew the 2 screws holding the reduction drive and the motor. We can see that the reduction drive and the motor goes off the bottom part of the case, and here we can see 2 end switches which disconnect the motor from the power source when it is at its end position, and the main gear which turns the valve. Okay, we can see the reduction drive. It has some metal gears, this gear, this gear, this smaller gear, and this gear which is on the motor. Probably the motor gear is made of brass because it was pressed down the shaft of the motor. With a plastic you can go this good. Okay, nothing interesting here. We've seen all we needed. Now let's place it back, placing the wires so they do not make make a mess. Okay, it's done. And assemble it backwards. We can see that the bottom part of the cover has a ridge around it, perimeter, which goes into the groove of the bottom part, and it's sealed with a rubber gasket. You can see it, it's black, so it protects this part of the device from water and moisture and so on. Okay, now let's assemble it down, close the case. Okay, now let's check if everything's okay. Put a piece of white paper so you can see that it is okay, and let's power it up. It opens and closes well. Now let's measure the current consumption. Let's take our device for measuring. Unfortunately, I cannot take more accuracy. I'll set it at 20 amps. Powered up, and let's see. Plus goes to plus, and now it's closed, and let's open it. 40 milliamps while opening, and about 10 milliamps powering the relay. Okay, now closing. About 25 milliamps, 20 to 30 milliamps while closing, and again open, and close. Okay, everything seems to work perfectly, and as you see, you may control the valve position, whether it's absolutely closed or absolutely open, by controlling the current flowing through the circuit. Well, thanks for your attention. Have a nice day. Goodbye.